Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore a multimodal LLM called Idefics. Now, Idefics is a model that has been developed by Hugging Face. The team of Hugging Face, they have a different units who work on different projects. One of the team has developed this LLM. Now, Idefics is an open source reproduction of a very famous model named Flamingo. Now, Flamingo is a model that has been developed by Deepmind. Deepmind is a Google company, and Hugging Face then reproduced it and made it available in the open source space. Now, Edifix is really powerful. But then there are reasons for that. We'll see that it's as equivalent or even par than some of the closed source multimodal LLMs. Okay, we have a few multimodal LLMs nowadays that we have been using. Lava, for example, Idefix is the other one. Then we have the closed source. We have Gemini by Google. We have GPT-4 Vision and some of the other models as well. Now, here in Idefix, what we're gonna do is we're gonna try out a few of the visual question answering tasks. We'll see that if it's able to describe the image of different types and if it's able to generate the stories or narratives or it's able to caption it, solve use cases like generating test cases for software engineering or describing an image or also telling you how to cook a pizza from an image, right? And those kind of things. So Edifix is available in two different variants. We're gonna use the 9V variants in this video. Yeah, we're gonna use Edifix 9B instruct. So we're gonna use the instruction model that has been further fine-tuned on the base model, which is Edifix 9B. Now this Edifix model, which is more, if you read it says image aware decoder enhanced. The decoder part has been enhanced even more, so the model will have a better understanding of images. It gives you intricate details. If you compare this with GPT-4 Vision, I have checked that for a few of the use cases. It's really powerful. Now, to use Idefix, we're gonna use a premium GPU because we're not gonna use any quantized model over here. We're going to use the instruction model that's available on Hugging Face. So we are going to do this exercise on RunPod because I have A100 available on RunPod. On Colab Pro, they don't give A100 even on Colab Pro subscription nowadays in the region I am currently staying, and that's really disappointed to talk about because I have a Colab Pro, but they don't give A100. They always redirect it to V100, which I really don't like. Now we're gonna use this in RunPod. We're gonna set it up in RunPod, install the weights, and try inferencing it on different visual question answering tasks. So let's jump in and see how we can experiment with Edifix 9B instruct a multimodal LLM. All right, so we are going to experiment Edifix in RunPod. You can see I am using RunPod. My CPU has been 100% utilized and I have some space left in my container because we have the model weights downloaded over there. Now you can see my GPU memory 22%, which has been consumed. Now to use Idefix because it's an extremely big model, I will say it's extremely large in size. It has two variants, one 80B and the other one is the 9B. Just to inform you that if you want to use Idefix in your application, you will not be able to do this in Colab Pro if you don't get A100. So if you are fortunate enough to spin off A100 within Colab Pro subscription, then you'll be able to inference this large vision model. That's why you can see I am in RunPod. I am on a A100 80GB GPU. It has an 80GB of virtual RAM, 16 CPU, and 125GB of RAM. And I'm going to use the instruction model of Idefix. Now, Idefix is developed by Hugging Face. Okay, if you come on this repository, you will know more about them. The dataset that has been used to train is Wikipedia, Hugging Face. They have used Obelix and Leon to you can find out dataset used to train. Over there, there's some information about it. Now, the good thing about Idefix is that it's as equivalent and even par than the other closed source vision models or closed source multimodal LLMs. Okay, and The model can answer questions about, you know, images, generating stories, describing visual contents, and it's open source. So you can also use it in within your infrastructure. You can deploy it within your infrastructure, within your network. You can keep it completely on premise as well. Now, Edifix is based on it's an open access reproduction. You can see it says of Flamingo, and Flamingo is a model by Deepmind. If you are not aware, you can read over here. It's a closed source vision model by Deepmind named Flamingo. Google also uses it in few of their products, and Idefix is based on Flamingo. It's a reproduction of Flamingo in open source uh, space. Now you can find out information about Idefix here. Like as I said, two variants, 80B and 9B parameters, and of course they were further fine-tuned on instruction datasets, and then they have Idefix 9B instruct and Idefix 80B instruct. And you can find out some details. It's a multimodal LLM. Hugging Face has developed it. It's a C license. You can read the license here. It's based on two unimodal. You can see two unimodal open source model, and you can find out Clip Vision Transformers and Huggy Llama 65B by Huggy Llama. Okay, and you can find out over here that how they have trained on further on this on supervised fine tunings and instruction fine tuning datasets, and you can find out the uses, and there are some examples how to use it, and so on and so forth. Now, to do this, let's come here. You can see I already have downloaded the model because it takes a bit of time to get it here, and these are the required dependencies. If you are using run pod A100, then you have to install these versions, otherwise you might face some challenges or you will get some errors due because run pod have their own containers that they spin up the notebooks. There might be some version conflicts. Now, the first thing that we are doing here, let me make it a bigger so you can see it clearly. Now, what we are doing here is we have our torch that we are going to use, and then from transformers, we are using Idefix for vision text to text and auto processor. We are first checking at the device if we have CUDA. If we have CUDA, otherwise CPU. Of course, it will not work on this kind of CPU that I have, but probably you need better CPUs to work with if you want to do that. Model name we're going to define Idefix 9B instruct, and then I'm going to use Idefix classes to load the model from pre-trained using a bfloat 16 or bf16 over there, you can see. And then I'm having a processor to process auto processor, and then I'm using some generation args. Okay, you can see processor.tokenizer end of utterances, add some special token which is false, and then bad words IDs. Okay, so there are a couple of generation arguments that I'm using. Now, how can we use this? That's the question. So let's try it out. So what I'm going to do here is I'm going to get from pillow. I'm going to use pillow import image. So let's do that. And then I'm going to load my image. I have a couple of image. Let's open first Elon image over here. You can see it's an Elon Musk image. He's doing something where he's standing, is posing in front of his Tesla. Okay. Now image, and then I'm gonna write image dot of course open. I'm gonna use this function, and I'm going to pass this image name which is elon.jpg. You can also pass your URL also directly. You can also do that. You can see this is the image that we have over here. Now I'm going to write a prompt. So let's have a prompts variable. We're going to write the prompt. Inside this prompt, the first thing is user. This is how you define. This is how the schema is of Idefix. And then I'm going to pass my image and then say, here is what my text input is. This is going to act as an input where you are prompting the model to perform some task. And I'm saying describe. So let's do describe this image. Okay, something like this. Okay. Now after that, you're gonna have assistant. The model will respond something. So let's do that. Assistant. Cool. Now this is what my prompt is, and I'm gonna have inputs equals. I'm gonna pass in processor. So processor, and then you're gonna pass your prompts and whatnot. So you're gonna pass your prompt thingy over there in processors. So let's do that. So you already have model with my processor, and if you can see early in the above cell. Now here I'm gonna passing prompt. So prompts and then return tensor. Okay, so return tensors, and then you're gonna keep PyTorch as a tensor, and then let's keep debug equals true to find out if we get something wrong. And we have to bind this with CUDA. So let's do to device, and that's what I'm gonna do here, to device. And then we have generated IDs. You have to generate IDs, right? As usual. So generated ID is, and then model.generate. So let's do model.generate here. And in this, I'm gonna my pass my inputs, excuse me, inputs and EOS token ID. EOS token ID equals, it goes exit condition. Do we have exit condition? Yeah, that's right. And then we're gonna have exit condition, and then bad words ID. If you don't define them, they will use what is there by default. It's also available on the Hugging Face repository. Bad word ID is, and then keep a max length. So let's do a max length of, for example, let's keep it short here just to save some time. So generated IDs, and then now generated text. So generated txt equals processor dot batch decode. So we're gonna decode that, and what we're gonna decode is generated ID. So generated IDs, and we can skip some special tokens. Let's keep that true. Skip special tokens equals true, and then I'm gonna give cool, and then just generated text. You can see what it shows you. It says describe this image assistant, and it explains the image to you. It says the image features a man. Let me make it a bigger so you can read it even more clearly. You can see this is the response that we are getting. Describe this man is wearing a black suit, blah blah blah. Fantastic. uh, Black suit. Let me make it a bit smaller, it's like too big. Okay, man is wearing a black suit and tie, and he appears to be posing for a picture in front of the car. The car is parked on a street, and there is a garbage door visible in the background. Where is that garbage door? Garbage door. Is this a garbage door? Probably. I don't know. This is garbage door. Okay. Garbage store visible in the background. Describe the image features a man standing next to a white Tesla. So you can understand it gets a Tesla thingy, by the way. It's a Tesla's electric car. So look at the intricate details that it's able to derive from the image. It probably from a logo or from the structure of the car. So it's smart enough to get the detail, which is really fantastic. Tesla model electric car. The man is wearing a black suit, and he appears to posing for a picture. Probably what I can also do. Let's try that with chat GPT here. Okay, now I have a GPT-4 access, as you can see. Probably I can upload this image. I just want to try it out, so let's try it out. Let's use describe and describe the image in 100 words. By the way, I'm using the chat GPT web client, and I'm 100% sure that the backend, that the way use, it's different than when we call them through an API. So this will always be better if you compare the outputs with your API calls, okay, that you do it programmatically. But let's try it out. Describe the image in 100 words with it also gets that it's a Tesla model, which this is what I was wanted to check. The man is dressed in gray blazer, a bit more 100, like it's 100 words, so it gets it. White tent-like structure. So it gets a tent-like structure, and Idefix was saying that it's more of a oh, excuse me, not garbage. My bad. It's garage door visible. Okay, that's correct. So bad. So garage door visible. Okay. So this seems to be doing well. This is fine. Okay. Now we can also show some special characters that injected around the images. If no, we can do that as well if you want to do that. But uh, now let's try it out about something like uh, how to set instructions now. I'm just thinking. So for that, let's try it out one more time. So I'm gonna have image equals image dot open, and in this open, I'm gonna pass my img hyphen, and then I have a pizza image. So let's call it pizza dot jpg. Let's try it out with some complex instructions now, and you can see it's a pizza. It's a pizza image that I have. You know. Uh, Okay, it's a quite a big image by the way, but let's try it out if it's able to. Otherwise, we'll take some other image. And then I'm gonna set my prompts here. So prompts equals again. I will copy this thingy here quickly. Copy, paste. Okay, this becomes smaller, so I'll again make it larger. You can see it. Okay, prompts, prompts. And let's close that. Okay, now prompt is there. User, and then you have your img. Hmm. Now let's say I will write. Mm, how do I make this? Okay, I will ask this. Think step by step and then answer. Something like this. Okay. And then let's keep this again. Copy, copy. Okay, and we are saying okay, generated ID is model.generate. Uh, here will not keep model.generate inputs EOS exit condition. Here I will not keep 100. 100 is too less. So let's increase the maximum length here. So I'm going to keep 1000 as the maximum length. That max new token is 1000. Then generated text processor dot batch decode generated IDs is skip special tokens true and then print generated text. So which is okay. And let me just get the generated text in a print. We should have used some console print or something to get the answer in a more beautified way. So this is what we are doing, and let's write out the answer for this time. No such file. Okay, okay, this is not image. Okay, this is only pizza.jpg. Okay, how do I make this thing step by step? And I'm pretty sure that in once you pass this image through pillow, there would have been some compression techniques that it will use to compress that. You can see now. Oh wow, it gives you an answer which is quite long and looks good. You can see it says, how do I make this? Think step by step and then answer. Then assistant is there. To make a homemade pizza with a thin crust, you will need the following ingredients. Pizza dough, mix flour, yeast, sugar, salt, and water in a bowl. Okay, I don't know how to make pizza, but I think after reading this, I'll be able to do something like this. Uh, Knead the dough until it becomes smooth and elastic. Wow. Cover the dough with a cloth and let it rise for about an hour or until it doubles in sizes. Okay, and then you need a sauce. In a saucepan, heat tomatoes, garlic, and basil. Cook until the tomatoes are soft and sauce thickens. Okay, season with salt and pepper to taste. I reckon I have to order a pizza now after creating this video. Cheese, shred or grate your preferred cheese, mozzarella or combination of multiple cheese that you want to do, toppings, assembly, bake, and serve. Wow, I love this response. This is fantastic. This is a great response. What kind of questions we can ask here? So let me just do one thing. Let me take a screenshot of, for example, mm, let me go to OpenAI dashboard here. Okay, I'm gonna go on OpenAI platform and okay, this is the platform and let me take a screenshot of this. Let it up. Okay, I'm on assistant. Let's make these changes to chat or something. Now I'm on chat or on chat. I'm gonna take a screenshot of this. Okay, so let's take a screenshot. Okay, I'm going to take a screenshot of this and I'm going to let's upload that image from my pictures and screenshots and then here is the image. I'm going to try it out for a test cases generation. So software engineering kind of an use case. So let's rename this and see if it's able to generate test cases for this image. Okay, so test.png. So I'm just going to copy this here. Let's copy and paste and then make this as test.png. Let's try it out if it's able to. Let's set it up here. Can you generate, or not can you, let's make it more deterministic. Generate the test cases in the given image. Identify all the components and then write the test cases. That will help the testers. That will help the testers in software engineering. If required, write the test case snippet, test case code snippet as well. Let's try it out, guys, and see if it's able to do that. So I have a max token as 1000, and let's try it out if it's able to derive. It's a very complex problem, but let's see what it does. It says I'm sorry, I cannot generate test cases as I'm a text-based program and don't have capability to display images. However, I can provide you with a general outline of these steps involved in writing test cases. Repeat steps until 3 5. That makes sense. Document. Maybe probably I'm not prompting it right, but yeah, this is okay. Now, let's try it out something else. Yahoo Finance. I'm gonna search about MSFT. Okay, MSFT. Try later. I don't need this. Whew. Let me take a screenshot of this again. So F2 print screen, and I'm going to ask about this now. If it's able to get this, again, let's upload over here. I'm just testing the capability of this, guys. Okay, how capable is this model? Where is that? A screenshot. Okay, let me just do a rename, and I'm gonna rename this as to chart.png. Let's ask this question. So let me ask this question now. And remember, we are using Idefics here. It's an open source large vision model that has been reproduced from Flamingo. So Flamingo is by Deepmind, a Google company. Let's try it out. Okay. Uh, I'm gonna use again the pizza thingy. Pizza thingy prompt was better. Okay, so let me just use that here to. Okay, and let's do that and remove test with chart. So I'm gonna remove that with chart PNG. So let's do that, and you can where did I make the change? Okay, here only. Fine. So chart. What do I did? How do I make this? Oh no, not how do I make this? Excuse me. I'm so sorry. How do I make this is not. I'm not sure where did I made the change. Oh, I didn't make the change. This is so bad. Okay, let me just. Okay, chart is here. So let's just remove this. How do I make this? Let's call describe this image. Describe this image. So I'm asking describe this image, think step by step, and then answer. It says the image displays a stock market chart of Nvidia Corporation, which is wrong. I don't know where it took Nvidia. Is it somewhere Nvidia that you see it? I don't see it. So that's a wrong response. But probably it's not able to find out from here. So we're just going through the curve and trying to say about the training data that it has seen. Over a period of 10 years, the chart is divided into different sections. So very bad. So it's not the right answer for this. But let's try it out some other examples very quickly. So one other thing that you can also do, you can do one sort and few sort prompting with Idefics as well. You can do that. Zero sort, we've already seen. These are all zero sort examples. Let's try it out. Let me show you how you can do one sort as a last example. Maybe you can try it out. So let me just do that. So for that, you have to keep everything kind of same. So let me show how you can do it from URL as well. So let me just copy this from here and paste it. and replace this with your URL thingy. So URL equals, I have a couple of URLs that I have copied. So let me just copy this. Let me just copy this image. To I'm gonna copy this image here. hmm let me just get this here. So I will copy this here and I will give the earlier one in the examples. That sounds better. Now URL, and then we'll have our image. Then we have to first fetch that. So right now you can see we are using an URL here. So for that, what you have to do is you have to use this URL to fetch the image. So I'm going to use image processor. It has image processor, and then you're going to use fetch images. Okay. So fetch images, I'm going to pass this. So let's give fetch images, write URL, and then write and okay. Now you can use the image or the URL. So I'm going to keep, let's remove all of this for now. Okay, let's write it from scratch again. Now you have your prompts, user will remain the same. So let's write user, and after user, then you will have your img. So image will be there now. And let's again write describe the image. So let's do that. Describe the image. And now what I'm going to do is, okay, you're going to do your assistant thingy. Assistant, and here I'm going to write an image. Let me just show you this. Okay, okay. Hmm, copy, paste. If you open this, you can see there are two, there are like cats, there are kittens, there are two kittens in grass, right? So let's use that. So I'm gonna write an image of two kittens in grass. Okay, this is the one shot example. So let's write one shot example. This is the assistant. Then you're gonna write again the user, because we are using uh, a one shot prompting here, and then you're gonna give your HTTPS of image that you have. So let me just get the give the other image. So if I show you this image, so let me just copy and paste. You can see this image. There's a dog image, right? So let's keep this image now. Of course, you can try it out with your images. Okay, now dog images, and then I'm gonna write here describe this image. Okay, describe this image, and then you give assistant. Okay, then you give, let's give a space here, assistant, and then you can see you have inputs, processor, and then prompts, return tensor, and debug true to device is correct. Then generated ID is model.generate inputs, EOS token ID, exit condition, bad words ID, bad words, and max length. Let's keep it short. This is too big. 100. Generated ID is processor batch decode, and then this is right. So now let's try it out and see. It says you can see the output we got because we are on A100, that's why it's pretty fast. But if you're on other GPUs, it will take a bit of time to result. You can see a dog wearing glasses and a tank top. Okay, fantastic, right? So this is, you can see this is the image, right? A dog wearing a glass, it's black glass or something. It's wearing a specs. So this is how you do one shot prompting here. You can do one shot. You can ask questions about text. We already tried zero shot inferences earlier, right? Yeah, so you can also generate a story. You can also generate a story out of it. You can do a lot of other use cases that if you want to implement with Idefics. Yeah, so this is what I wanted to experiment with this large vision model, and I hope you understood that how you can use Idefics now. This code will be available on my GitHub repository, and this ends our experiment with Idefix. That's all for this video, guys. I hope you now understood that how you can use Idefix in your use cases if you want to implement different use cases involving RAGs or visual question answering or other use cases in software engineering, how you can use this multimodal LLM or the large vision model named Idefix. The code will be available on GitHub. If you have any question, thoughts, or feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. Please find those details on my channel banner and the channel about us. If you like the content, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel. Share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.